In this unit, we are going to learn about polygons and circles and inscribing polygons in circles. So the first thing we need to do is just review some information about polygons. So polygons are simple closed shapes that are made up of line segments. So the key thing here to remember is that polygons are made up of only line segments, so no curved edges. And when we say they're closed, it means they're completely connected, so there's no openings in them. A regular polygon is a polygon with all equal sides and all equal angles. So a polygon with congruent sides and congruent angles. So if you think about a three-sided polygon that has all equal sides and all equal angles, that would be an equilateral triangle. So meaning all three sides are equal, all three angles are equal. Or a square for a quadrilateral, all three sides are equal, all four sides are equal, all four angles are congruent. So those are just some examples of regular polygons. So I talked about kind of here the first two, triangles, quadrilaterals. You've heard of those. You've heard of all of these, but just as a refresher, so you have 5 sides, it's a pentagon, hexagon for 6, heptagon for 7. I've also seen septagon for this, so either or would be acceptable. Octagon for 8, nonagon for 9, decagon for 10, dodecagon for 12. Notice we skipped 11. So anything that's not listed here, you are just going to name by the number of sides. So what that means is 11-sided figure, we're just going to call an 11gon. Or a 22-sided figure would be a 22gon. So that just means how many sides. Keep in mind that the number of sides is also going to be equal to the number of angles. So if there's 5 sides, there's going to be 5 angles. So I'm going to add that as well. So number of sides will equal the number of angles. So some other terms we need to talk about if we move down to the bottom here, labeling the sides versus vertices of the polygon. So sides are just the segments here. So this is a side, this is a side here, and this is a side. And then the vertices are just the points. So this is a vertex, this is a vertex, and so is this. I'm just going to draw arrows to those. So these are all vertices. Singular would be vertex, if I wanted to label them. And then the next is the interior versus exterior. So it makes perfect sense to say that the interior is inside. So this would all be the interior. So it's inside the polygon. The exterior then would be all of this outside of the polygon. So anything outside. So this is all the exterior. And then the other vocab word is an inscribed polygon. So what does it mean for a polygon to be inscribed? So a polygon that's inscribed is a polygon. So it's a polygon whose vertices are on the circle, or on a circle, I'm just going to say. So if we start with some circles, so let me just grab, let's get some circles drawn here. So if I start with some circles, just give you some examples. So I'm going to draw the first side here. I'll say that these are inscribed. And these will be not inscribed down here. Let me just move these. So if we're talking about inscribed, that means basically start with some points on a circle. It doesn't really matter how many points you have, and connect them. Let's see, put another one here. So this would be inscribed because there's every single vertex of this polygon is on the circle. So another example, let's just say I make a triangle. Again, inscribed because the points are on the circle. So an example of something that's not inscribed would be something like this, where my one vertex here, so this vertex in red, is what's causing that polygon from being inscribed, because that vertex is not on the circle. So another example would be something, again, it's very similar. So if I take and connect these, might as well finish up making a star here. This would not be inscribed as well because of these points that are not on the circle. So even though some of them are, we have some that aren't. So those are your examples of inscribed versus not inscribed. So if we go to the next page, we're actually going to do some constructions with inscribed polygons. And there's 3 that you have to know how to construct. The first one being a regular hexagon. So a regular hexagon will have 6 congruent sides and 6 congruent angles. And all of the vertices will lie on this circle. So what we're going to do, so grab your compass and your straight edge. And the very first step is you're going to place a point somewhere on this circle. The center of the circle is O. So I'm going to place a point, let's just say right there. I'm going to call it point P. So I place a point anywhere on the circle. And then the next step is going to be to measure the radius of this circle. And this is what I'm going to use to be able to construct the 6 equal sides. So the radius of the circle is going to go anywhere from point O to a point on the circle. So in my case, it's going to be point P. So let me just mark that, showing you that I did measure that. So there's my first step, measure the radius. The second step is now going to be to take my compass, keeping that radius the same, that's important, placing my point on point P. And once you get point P, you're going to go around the circle. So you're going to mark that. So you're marking that distance around the circle. So then I move my metal point onto that arc, and I repeat the process. And then I do the same thing. I'm being very careful about making sure I'm trying to be as accurate as possible with this, because what our end goal is to get our compass, our last arc, to go through point P. And if you're not being accurate, it's not going to lie perfectly on that point. So if we actually take this, put that metal point, we should see that it's passing through point P. So you have all of these arcs that are the same distance as the radius. These arcs represent the points of your hexagon. So I'm going to go ahead and just mark those points now. So those are my points. And then I'm going to use my straight edge. I'm going to connect these points. And you should see what looks to be a regular hexagon. With 6 equal sides and 6 equal angles. So again, the steps, I place point P. So if you want to write down the steps, you place point P anywhere on the circle, measure the radius from O to P, and then once you have that radius, you place the metal point on P, draw your first arc using that radius, place your metal point on that arc, draw the radius again, and then just continue around the circle until you get back to point P. So there's your hexagon. The next construction is going to be basically starting off the same way, because now what we're looking at is constructing equilateral triangle. So instead of 6 equal sides, well, we want half as many. So what we're going to do is we're going to use the hexagon construction, but we're only going to connect 3 points, because an equilateral triangle is going to have 3 congruent sides and 3 congruent angles. So that means for this one, we're going to start off the same way, get our hexagon vertices, and then we're going to just connect 3 of them. So I'm going to walk through the construction again. So I'm going to place a point on the circle, call it point P. This can be wherever you want it to be. It doesn't have to be in that same spot. Anywhere on the circle. You're going to measure your opening very carefully. Try not to make your points too large as well, so that you make sure that you're actually getting an accurate representation of where that point should be. So here's my first measurement. Then I'm going to take and mark this around the circle. And just continue this. So making sure, again, I'm trying to make sure that metal point is right on that intersection. Go all the way around the circle until you get back to point P. Keeping your compass exactly the same opening or the same width, meaning the radius of the circle. Again here, making sure I'm drawing this accurately. And then go ahead and connect. So here's my point. I'm just making, this is a little bit off. I think these circles are a little bit distorted on my computer, so I think that's playing into this as well. But making sure that you're making your arcs and you're using your metal point right on the center of those arcs. So when I go to do this, instead of connecting all 6 points, that would give me a hexagon. I am going to use every other point. So that means if I use point P, I'm going to use this point, and then I'm going to use this point, and I'm going to connect those. So I'm connecting every other point here. So when I do this, go ahead and connect those, and there's your triangle. It didn't have to be those 3 points, but it has to be every other point. That way you're keeping that distance the same between each of the points. So there's your inscribed equilateral triangle. The last construction here is using your compass and straight edge to construct a square. So this means if you're looking at a square, you're going to have 4 congruent sides and 4 congruent angles. So this construction is going to be a little bit different because you're not using the 6 vertices that we did in the hexagon in the first example. So for this one, we're going to construct the diagonals of a square. And if you know anything about the diagonals of a square, which we'll really talk about later on in the year, but the diagonals of a square are congruent and perpendicular. So we're going to basically use that information to do this construction. So the diagonals of a square, if they're congruent, what I'm going to do is I'm going to first draw in a diameter. So if I draw in any diameter, so that means it's got to pass through the center and it has to go from both sides of the circle, so it has to touch both sides of the circle. If this is my diameter of the circle, any other diameter in the same circle will be equal to that. So if I make this the diagonal of the square, I know that another diameter would also work, but I have to make the other diagonal perpendicular to this. So I draw on this diameter, and now I need to go perpendicular to this. So what I'm going to do is I'm going to do the perpendicular bisector construction. So I'm going to take my compass and go more than halfway. Do the same thing over here. And now if I take and I draw a diameter that goes through this, it's going to end up being equal to this diameter and perpendicular to that diameter, which means that I've created the diagonals of my square. So what I'm going to do is I'm going to first start with just showing you, you would take your straight edge and you're going to hold it up. This line's perpendicular to the diameter because it's passing through those intersection points. And then what I'm going to do now is let's actually draw in the other diameter. So going from here through the center to that other intersection point of the circle and the line segment, that is the other diagonal of this square. So basically these two diagonals are congruent to each other and perpendicular. They're congruent because they're both diameters, and they're perpendicular because I did the perpendicular bisector construction. So therefore, my 4 vertices of my square are these 4 points right there. So now the last step is just to connect those, and you'll have a square. And there you have it. So there's your square because it has 2 congruent diagonals that are also perpendicular. So these are the 3 polygons that you need to be able to construct, and we're always going to be looking at the constructions first in a circle. So using your circle and making these inscribed polygons. So on the next page, you'll find a spot to write down your key ideas from the video, and then a place to practice these constructions. So go ahead and complete that.